So very nice to talk to you. This is Jean-Baptiste talking. I'll be first presenting the return of experiments and on the different feasibility studies that we've been browsing through with the UNHCR. So as for us, we are a non-profit organization. For those of us who don't know us, we gather high-level technical experts and devote our time to promote the access to the most efficient, sustainable energies that are available and develop partnership with NGOs. What we do mainly, it's about technical studies, so energetic assessment, technical studies, tenders assistance. In most cases, we work on solar pumping, but we can also work on other renewable. We are also build training sessions, and we are working at the moment with the UNHCR on IT tool design. And we really like to share our knowledge in such an event. Next slide, please. So considering our experience we had with the UNHCR, we have worked in 5 different countries on a dozen of solar pumping feasibility studies. And we've been working at the different steps of technical study for solar pumping, from water system assessment till works assistance. And we've encountered very various specificities, like from intake in rivers or boreholes, from very simple drinking water supply, like just one tank, one pipeline, one well, and sometimes very much complex with a certain number of wells and pipelines connected to each other. So from 5,000 to 50,000 people, it gives you an overview of the different kind and the different range of projects we have been working. Next slide, please. So our 2 key learnings from all those experiences is that first time, the long-term vision is quite complex because when you are looking at making a solar pumping project, you want the installation that lasts for 15, 20 years. And most of the time, it's very difficult to project yourself in a refugee camp in such a long time. So because there are volatile contexts. For example, in 2019, we wanted to go on in Niger for a mission of water assessment. Was not possible to the humanitarian crisis. Also point, the facilities are mainly built in emergency and not easy compatible with solar pumping. So we worked on Chad or Mauritania, and sometimes the water system is so complex that it's not easy to fit with solar. So please, our first advice will be the selection of the compatible camp is key and the compatible system. The second point is that the data collection is, in most of the case, very challenging. There is a high turnover of IPs and UNHCR people. The data archives is often an issue. We wonder about a camp in Cameroon, and after a few months after having put the report, we just understood that there was some data that were hosted by a previous partner, and they were not available when we organized the mission. And last, because we have to organize mission in the field to evaluate specific figures and to make a good evaluation of the cost, we encounter security and logistical issues. So sometimes it's beginning complicated. So our advice on this will be to enhance the EDM to support operational efficiency and project design. So EDM is electronic document management, to help people design the best way the installation. Next slide, please. Okay, so thanks to those learnings, we have thought on a quick and easy to use tool in 3 major points. First one, facilitate data collection, as I've just said before. Avoid sticking to the pump manufacturer's tools because they target you their own products, and they don't take into account the complexity and the network that you have, you may encounter. And then also try to get the best estimation, but the quickest way, and from people who are not as professional in hydraulics or solar. This was the main things that we thought it was structuring the tool we were working with the UNHCR. So considering this common experience, we decided with the UNHCR to build a tool to reply to this necessity. So next slide, please. So the objective of the rapid assessment solar tool that Ayman is going to show you is first give an easy access to the drinking water network thanks to an ergonomic interface. This will reply to the need to people who are not specialists to fill all the data that is needed. Then try not to reinvent everything because there is an existing borehole database in the UNHCR. So our main focus was to create a new database that was compatible with the existing one. Then simulate the solar potential and the cost of the works, of course, and deliver a report very easy to read with the main characteristic of the solar pumping potential. I let Ayman proceed and let's give you an overview of the database.
So thank you, Jean-Baptiste. Next slide, please. So I'm gonna have a few words about this rapid assessment solar tool and mainly how it works first. So it was designed for UNHCR WASH officers on the field that have the credentials and the power to collect data from the field and upload it towards the UNHCR servers. So it will be done through an ergonomic UI that will help upload the necessary data with possible communication protocol with the existing databases and a background working calculus core that will generate a report. Said reports will be public on the GIS portal as soon as they are generated. So on the next slide, we will see the main inputs and outputs of this kind of tool. So first of all, we will use weather data meaning solar irradiation and temperature data that will not be provided by the user, but it will be taken from an outside source. The user will have to provide data about the hydraulic network in his camp and the installed equipment, because we are targeting mainly existing camps in order to rehabilitate them and to install solar power to these camps. And data about the distribution profiles, the water distribution profiles, will be assumed by the calculus core, so not to overburden the user with lots of data inputs. So our background calculus core will be able to give as an input the solar potential, the amount of water that is produced via solar power with respect to produced by the camp, an estimation of the cost and the cost efficiency in order to have a better view of the resources needed and where best to direct the UNHCR and the UNHCR resources, and at last we will have an estimation of the CO2 impact in order to have an ecological impact of the project at hand. So the next slide will be a quick view of the UI and it's the way it is built. So we aimed to build a UI that is very simple with very few inputs at each page or each view, as we call them. So first view will be a global assessment of the project, in which the user will have to enter a name, a location, and a population that will need water. So on the next slide, we will see a pump. We will see the pump view, in which the user will be able to enter key figures about as many pumps as is needed or as is present in his camp. So we have types of pumps with key figures and key characteristics of pumps, pumping rates, depths of pump, electric power, etc. So this will allow us to have a flexible tool that does not just focus on simple networks. So the next slide will be a view of the water source view, in which the user will be able to to enter data about the water sources. Will be boreholes, rivers, source captures, etc. So the key data will be the drilling depth, the water levels, static and dynamic, and the nominal source flow. So again, same as with the pumps, we can add as many as necessary in this context. So on the next slide, we can see that not only new data can be used, but existing data from the UNHCR database, provided the user has the credentials, can be loaded into this tool. So it's a way for us to value the data previously acquired by UNHCR. So next slide will be about the power sources. Panels, will it be solar generator or hybrid? It is about the power that powers the pumps and the hybrid and the solar or hybrid networks. So next slide will be about the storage points, which were not present in the previous UNHCR databases. So we had to add that in order to complete the information. And the next view will be adding singularities or nodes to the network. So we have a broader view possible of the network, and it allows us to assess complex networks and complex installations. So the last slide of this UI will be a summary that will happen after the pipe view, which I didn't show here because it is quite long to explain. So at the very last of the data input, the user will have a feedback in order to have a good feedback and assessment of his network. So at this step, the calculus score will take place and will provide us with a report that is visible on the next slide. So the report generated by this tool will be 2 pages long. First page is a summary of input data in order to present the context, the number of water sources, about the number of water storage points, and a quick view of the structure of the hydraulic network. The second page, which is what is needed from this tool, will be the output figures. So there is a line about solar figures, which are the first line is about solar figures. So it is about the peak solar power to be installed and the solar share for each pump. A line about water volume figures, amount of waters produced each day under scenario. A line about fuel figures will also be available, and a quick economic overview with a ballpark of the investment and the payback time. So to conclude, we have built for UNHCR a flexible tool that will allow us to assess potential to solarize existing camps and existing installations. And thank you for your time, and don't hesitate if you have questions.